Okay guys, so we wanted to show you how to use a circuit simulation that you don't have to download. So this one you're going to go to Falstad. I actually just searched for Falstad circuit, so Falstad in Google, and the first one that comes up, it should be like www.falstad.com/circuit/. Go ahead and click on it. You should not need to download anything. I don't know if you need Java. Cool. So, but anyway, they give you a circuit here. Usually what I do is I just delete it, but it's kind of cool stuff. So this is a switch here. And then once you flip the switch, you can see what's going on with the circuit. So I'm going to show you just how to build a really basic circuit here. So we'll start with inputs and sources. So you want a battery. Let's do a voltage source, 2-terminal here. And so we'll put that over there. And then let's draw some wires. And then let's start the simulation, okay? So it says stopped here, but as soon as I unclick stopped, it should start the simulation, okay? But what's the problem with this? We talked about this. This is short circuiting, right? So what we've got here is you have a voltage source here that has no resistance. This is really bad, really, really bad, okay? And so what we're going to do is we're going to add some resistance, right? So we'll go to draw, click add resistor. This is where you can get anything in here. There's a lot of awesome stuff in here. So I added the wires earlier, so we'll add a resistor now, and I will just stretch him along. It looks like he's coming in at 100. I don't know if that's ohms or milliohms or what. Let's actually let's right click him. If you have a Max, it's double clicking. And then you can go to edit, and then you can set the resistance, and it looks like here it's in ohms. So, all right, that's cool. We'll do 100. Hit apply, and then hit OK. Now, if you try to run this, it's not going to work because your resistor is not actually part of your circuit. So when you want to grab things and move them, okay, if I just try to grab this thing, it's going to draw another resistor, which is kind of annoying. You can actually hit Command Z if you have a Mac, or like Control Z, and it will undo that. It's a nice little shortcut. So let's actually get him connected. I'm actually going to take the wire I already have. Okay, so go down to draw and then hit select/drag select. Now what you can do is you can select certain things. Okay, so I'm going to take this corner here and get him attached there. And I guess I'll attach him there. Okay, so this is looking a little weird because it's not nice and square, but that's all right. So we'll come over here, we'll move him in there. Okay, all right, so we got our resistor. Maybe we'll come over here and then connect there. Make sure you connect on the corners, right? This one's going through. See how it says bad connection there? It looks like they're connected, but they actually connect at the corners. All right, so now you should be able to run a very basic simulation here, okay? And I'm going to actually slow the current speed down a little bit so you can see what's going on here, okay? So we got a current finally running through our source, going through our resistor here, okay? All right, now what's cool about these simulators is that at any point in time, if you want to know the properties of a certain part of the circuit, you can just mouse over the item that you're interested in, and it will give you the relevant information. So on this voltage source here, we're putting out 5 volts, okay? And it looks like our current is 50 milliamperes, okay? On this wire, that's great. Cool. Should be carrying the same thing. On this resistor, this is really nice. So you've got a current of 50 milliamperes, you got 5 volts, the resistance is 100 ohms, and the power, that's what P stands for, is 250 milliwatts, okay? So that's cool. So this is good. This is kind of a basic circuit. So let's make it a little more interesting here. So let's say that we want to build something a little more interesting. Maybe let's put a couple things in here. So let's do a resistor here. And then maybe we'll do another resistor over here. All right, so now you've got two resistors. If you can mouse over, you can see that the current now appears to be 25 milliamperes. So that's interesting. Looks like it cut the current down into half, which I guess makes sense if you have two resistors. Voltage here is 2.5 on him. The resistance still 100 ohms because we determined that. And the power is 62.5 milliwatts. So the power, wasn't it 250 before? So now it's 1/4 of what it originally was. So that's interesting. Let's play around with this a little bit. And you guys should do this on yours. So change the resistance on some things and see what happens, right? So if you change the resistance, this guy now has a current of 16.67 milliamps, which is the same as this guy over here. But we are getting some different things here, right? Notice how the power on this one is 55.56 milliwatts. And this one is 27.78, which I think is exactly half, right? Also, notice the voltage is double the voltage on this one. So that's interesting. So you guys should play around with these things and get familiar with what happens when you wire things up. Now, what's really interesting here is let's do something in parallel and see what happens, okay? So we've got our circuit. Let's bring this down here. And we'll create a parallel circuit here. And yeah, I know I have something that's wired up with no resistance. Leave me alone. All right, so let's drop another wire here. Then we'll bring a wire down to here. We'll put our resistors in right there. We'll make it nice and symmetrical. Okay, so we'll bring this over. Bring this over. Okay. All right, so we're going to drop some resistors in here. So now we've got a couple 100 ohm resistors. Let's see what happens with this. So again, this is nice. You can just put your mouse over this. This resistor, 50 milliamps, 5 volts, 100 ohms, 250 milliwatts. I was about to say megawatts. That mega would be million, and milli is 1,000th, right? So those would be very different, okay? And look, so you guys can play with all sorts of things, right? You could add a switch here, and now you need to actually connect the wires on this. So, oh, that's not what I wanted. So we'll draw that there, put that there. We can add a wire here, connect up the switch. Oh, there we go. So we're running our simulation. Stop it. We'll run it. Doesn't look like anything's happening because the circuit is not complete, right? But if we flip the switch, we'll get the circuit to work. So that is the basics of how to run this simulation. Like I said, you've got all sorts of options here that you can play around with. So if you've ever heard of a transformer, you could add one if you wanted to. Okay, well, have fun playing with that. Also, I was going to say one other thing. There are some things that may not look like they're in parallel, but they are. Okay, so it's important that you understand that this right here, this configuration is parallel. Okay, these are wired in parallel. I'm going to actually take this out, and I'll try to think of a good way to explain why this is in parallel and not series. I guess really what you need to ask yourself is as the as the electrons are moving along here, do they have the option to go this way or this way? If they have an option, they're in parallel. If they don't have an option and they have to go through everything, then they're in series. Okay. I believe that's all I wanted to tell you guys for this.